In this video, we'll look at question 28 from the 2016 exam.
So in this question, we have a pulley hanging from the roof by a coupling, and rope around this pulley by which a 5 kilogram box is hanging, and we are pulling with a force at the other end of the rope as to accelerate this box upwards with an acceleration of 0.8 meters per second. And as we are pulling, that creates a tension in the rope and also a force on the pulley, on the coupling. And that's why the question is, what tension the coupling actually will have to withstand in order for this lifting to be able to occur.
So there's a force acting on the box, pulling upwards, that's our force F, and also the tension all along the string. So that's something students sometimes struggle with. At every point on the rope, this force F, the tension, will act everywhere in both directions. So it's the same here, and most importantly, acting downwards on the pulley from both sides. We'll see that later. Let's now look more closely on the other forces acting on the box. So namely there's gravity acting downwards. So that would be 50 newtons, right? Because we have 5 kilos times 10 gravitational acceleration gives us 50 newtons. And now by Newton's second law, the mass times acceleration, which is 0.8 for this box, has to equal the resultant force, which in our case is F minus 50 newtons acting downwards. That's why the minus. And so F must be 54 newtons. As I've already said, this is the tension all along this string. It's the force with which we have to pull, the force acting on the box, but also the force acting on the pulley from both sides, from here and from the left-hand side. So the force the coupling has to counteract is, in fact, 2F, which in our case is 108 newtons, and that's the final answer. If the force was any less, the coupling would just break, and this whole mechanism wouldn't work. So 108 is our answer, and in the exam, that was option H.